This comes in and can only flow in one direction, which is through diode 1. It then passes through the load. Once the current passes through the load, it will then need to get back to the source, and as phase 2 is in the negative half of its cycle, the current will flow through diode 6 into phase 2. In the next segment, we see the current is still flowing in phase 1 and diode 1, but now phase 3 is in its negative half. So the current switches and the flow returns through this phase via diode 2. In the next segment, phase 2 is approaching its peak, so the current now flows through this phase and through diode 3. It then flows through the load and back into phase 3 via diode 2. In the next segment, the current flows still in phase 2 via diode 3, but phase 1 is now at its negative peak, so the current will flow through diode 4 back into phase 1. In the next segment, we see that phase 3 is now approaching its positive peak, so the current flows through this phase via diode 5. It then flows through the load and then returns via diode 4 into phase 1. Finally, the current flows through phase 3 via diode 5, through the load and then back into phase 2 via diode 6. This cycle just repeats constantly like this. The oscilloscope for the three-phase supply will see 3 sine waves for the AC electricity. But the oscilloscope on the load will see this as a rough DC electricity with some ripples in it. Now we need to smooth out those ripples to clean up the DC electricity. For this, we connect a capacitor across the positive and the negative. This capacitor is like a storage tank and will absorb electrons when there is excess, and it will inject electrons when there is a reduction. This will therefore smooth out the ripples in the DC electricity to a nice smooth signal on the oscilloscope. We have covered capacitors in great detail previously, do check that